Okay, we're going to get into some curves. And once again, what are the things that we graph when we are curving anything? What are those things? Tim, what's one thing? With any graph, what feature?
Cross.
The cross, the Cartesian plane, yes. Okay, that's good. Obviously, we start with that first. Zach, what's one? Intercept, okay. Which one?
X and Y.
X and Y. Intercepts, X and the Y intercepts. Sometimes there's two Y intercepts, but that's for other graphs. Let's keep it simple. Okay. All right. Anything else? Yeah. Turning point. Okay. Now we're into the topic where turning points are really important. It's the main feature. A turning point. What is special mathematically about a turning point?
Zero gradient.
Zero gradient. So this is a turn. You're on the hill. Okay, right there is a zero gradient. What is a symbolism that we use for gradient? Nathan, what if my graph is y, what's the symbolism, the notation for the gradient? Jesse, it is m? I want something else though. You're not wrong. Maya. Okay, there's something over something. Almost correct, Jesse. A dy on dx. Okay, that's the magic. Stationary point. So you can have that, or they can be stationary like that. Remember, how do we calculate graphically stationary points? Put our ruler, it's our tangent, line it up, put it flat on the surface, and make it travel. The moment that tangent is that flat, that's our turning point. Okay? And likewise, all the way around like that flat, and so on. So when it's dy dx equals 0, therefore, let's look at this first question here. Without even graphing, y equals 3 plus 4x minus 2x squared. If I want to do a dy dx, Harry, oops, 3. What do constant numbers turn into when we derive them? 0 disappears. Thank you. 4x. Zay, 4x. What does that turn into when we derive it? Okay. Can anyone help him out? Who remembers? Gabe? 4. When we get to polynomials, okay, Manny, what do I do with this 2 and this 2 here? I know it's the holidays. Things might have been erased. It's okay. Okay. You can tell him. Multiply, that goes down to that. So multiple of 4. Keep the negative sign. Once we action the multiplication, the new power is it's not 2. Which one? Goes down 1. Okay. So this is the graph, and this is the derivative graph. Now, what are we going to do from here? What's the next step? We want to find what's the key word, Tim, in this equation here. In the question, sorry. Stationary. Whenever you see the word stationary, that actions to a derivative. But then we've got to make that derivative. What are we going to do with that derivative, Emily? What are we going to do with our derivative equation? Make it equal 0. Like so. Okay. What are we going to do now? We have an equation that we can work with. Nathan? We're going to solve for x. Okay. So I'm going to move the 4x. It's easier to move a negative over. Saves you a bit of time. X equals 4 on 4. X equals 1. Question. Am I done? Why aren't I done? Exactly, mate. So we found our coordinate, but we don't know our y. How am I going to find my y? Jesse? Excellent. This will go into here to find coordinates. Do not put it back into here. That makes no sense. Just straight sub. Hope that's all right. So we have a turning point at 1, 5, and we're done. Okay. If you want, you can actually get your class pad out, graph that. Let's do that now, by the way. Get your calculator. Type it in. Graph 3 plus 4x minus 2x squared. Once you've done that, I want you to show me how you found the turning point. Okay, if you've graphed it, if you've ticked your box and it's not there, what's a good idea to do? Go to zoom at the top, go to quick and standard. That usually brings up the equation. To find a turning point, we go to, where do we go to again? Analysis, G-solve, and what are we looking for, a min or a max?
Minimum.
Okay, we're looking for a max. You'll see why when you get the graph. Okay. Are you?
No.
He's got a case. He's done it. Please show me that you found it. Oh, okay, yeah. Good. There's basically more proportional.
Never mind.
I feel it not more. Zoom. Quick.
It's really got like a full. Yeah. So I want to say
Okay,
time
there you
then. I just haven't been out.
I can go to Zoom, go to quick, and go to standard. Yeah. Good. And yeah. Okay. All right. So always check your answer with the CAS. Let's see this next one here. Right. Question B. Do not be phased that it's no longer a Y. If it's a B, keep it as B. Okay. So if I derive a B, what's my derivative? Okay, Gabe? What is it?
B.
B?
DB.
DB?
DT.
DT. Good. Okay. The b is the equation, the t is the variable. So you need to know how to don't get lost with that. Okay, 2 and 3 t cubed. What are we going to do, Maya, with the first one? We're going to derive it. Okay, 2 and 3 by 3. So 3 times 2 is 6. On 3 becomes 2. T power 2. Okay. Next one, 2 times 5 on 2. You can see that the 2's cancel out. We get a 5t 1 or t. Zach, minus 3t plus 5 becomes?
Minus 3. And that's it.
And that's it. Okay. Naturally, next step, Perry, what are we going to do with this? Subbing the derivative, and that becomes 0. Good. Okay. And what are we going to do here? We can do quadratic, yes. It's a surefire way to do it. Although it's long. But let's try some shortcuts first. What's a shortcut of this? You can sort of just try and null factor it immediately. Okay? If I have a 2t squared, what must the first two be? A 2t and a t. Okay? What must our two factors be if the last numbers are 3? What must they be? We're dealing with
Not minus 3.
okay, so we have a 1 and a 3. And the question is, which one is the negative? Okay. I already know the answer, so that's going to be the plus and that's the minus. And then you can just check that to see if that works. We know that works because a 1t with a 6t is a negative 5t in the middle. Okay, that won't work if that's a negative and it's a positive. Last step is a last step, null factor law. Let's go back to term 2.
You pretty much got to nullify one of them.
Nullify.
Find the other one.
No, we nullify both of them. You're almost right. Right. Okay. Null factor law. Okay. Okay. What's the observation? Who's got a good observation for me? Okay, you're onto it.
The domain.
The domain. Okay. Domain is up here. Gabe's keeping an eye on the domain. Therefore, we must eliminate our negative 1. We don't want it. Okay? You might lose marks if you don't check the domain. Okay? Now, what am I going to do? I'm not going to do it. What am I going to do with this, Nathan? How do I make use of it if I'm still finding the stationary point? What does a point consist of, Nathan? What are we going to do with the T3? Yeah, where? Into the first equation. Okay? We're not going to do that, but I'll show you the workings out there. Okay? Just to save a bit of time. Okay, let's keep going. Any questions? Okay. So with this one here, it's the last question for today, but it's a long one. Okay. Find the stationary points of this equation automatically. Maya, what am I going to do here? I'm going to automatically derive it from this keyword here. If it's fx, Maya, what's my derivative notation? It's not dy dx now. What is it? Sorry. That's okay. Benny had it.
The apostrophe.
Apostrophe. Okay. Okay. So we quickly. Okay, what does this become if I derive it?
3x minus 12 squared.
Squared.
3x squared, sorry, minus 12x
Yep.
plus 11.
Good. Plus 11. Okay. Now, what are we going to do here? What's the next natural step, Perry? Make it equal 0. Okay. What are we going to do now? Can anyone in your head, can you null factor law this? I'm telling you, unless you're a genius, you can't. Okay. You're all geniuses in your own way, okay? What is the surefire way to figure out our x if null factor law is something we can't do automatically? Tim said it at the start. What did Tim say? Beginning of the lesson. The quadratic formula. So the quadratic formula will always give it every single time. But the negative is that it's long. Okay? So if I do quadratic formula, if I'm solving this quadratic formula, who knows it off by heart? There's a b squared minus
4ac.
it's a 4ac.
And that's in the root.
And that's in the root.
And then b minus.
And the negative b
The whole one.
plus minus. Good. You need to know that off by heart. Okay. Jesse, what's my b?
Negative. Which is just 12.
Yeah, that's right. We'll get there, yeah. So negative 12 squared. What's my a, Zach? 3. And my c, Zach?
11.
It's 11. And 2 times 3. Okay, we've got to work this out. You can do it on your calculator, but it's best you do it on paper because you are always tested without a calculator. Okay, 12 squared, 144 minus 4 times 3 times 11, 132. It'll be a 6. Okay. 144 take away 132. So 12. Got a 6 there. Okay. Where do I go from here? What do we do? Okay. We can cut it up, but let's deal with this root 12. I want to kind of simplify it to root 3. Okay. But I'll just take a step back, Tim, just to show the working out. 4 by 3 is 12. Your factor must always be a square number. If it's not, you're still stuck. Like so. As Tim said, 2 root 3. And what's our answers? Okay.
0 equals 12 minus root 3 brackets 6 and plus it.
And just with a plus. So one's going to be a plus and one's going to be a minus. If you miss the other one, you miss half the marks. Okay. 12 on 6 is a 2. 2 on 6 is a 1 on 3. Like that. Like that. That 3 only belongs to the second one. Okay. What do I do now? Sub it in. Where do I put them in, Tim? I wish I accidentally wiped up. So I'll just write it out properly. When you do sub it in, make it nice and neat where the teacher can follow. If I sub in the first one, please do that. Okay, you're telling me that you're subbing it in. And each of these x's are being replaced by the value. Okay, like so. Now we're going to, yeah. Oh, did I? Oh, I did do the derivative. Thanks, Gabe. Let's do that. Thanks for the pickup. I did exactly what I didn't want you to do. So go back here. It should be, yeah. That's right. I made a mistake in my notes. Now, can everyone put this in your calculator, please? I'm after a decimal. Please get your CAS out. Or you might even use your normal calculator. Please do that. Please give me a number. Please give me a decimal. And can you also do it for the other one, please? So over here. Let's do. So you can type this in.
So it's like plus 1 you can get like negative 0.38.
Negative 0.38. Yeah.
And then like
Yeah, 8.9, something like that.
good.
Over here, if you put that in correctly, can anyone give me a decimal for here, please? What'd you get? Who's got the answer for me?
0.
Thank you. Okay. You can see this graph is quite symmetrical because one is a negative 0.3849, the other one's a positive 0.849. Okay. Now we need to answer the question, and we're going to do it like this. Bit messy. Okay. So we now know. Can someone tell me 2 plus root 3 on 3? What's that as a decimal? Can everyone do that? What is that, please? And someone else do what this one is, please? We want to put them into decimals so we know what we're looking for.
The plus is 2.57735.
Thank you. Can round that up.
And then the minus is 1.42264971.
Thank you.
How many go?
Just that's fine. Just a rough idea. Okay. So we still need this. Now, without cheating in a way, looking at the CAS, we know that 1.4 and 2.5, what's the gradient of these points here? 0. So they're big fat zeros. So that's a 0 gradient and that's a 0 gradient. Now, we now need to choose some nice x values to find out what's happening in between. Okay, so if I have 1.4 and I have 2.5, what's a nice value in between that I can sub in? 2. So I'm going to go over here. I'm going to find out what is the 2 doing. And what does that equal to? Okay. That's 12 minus 24 plus 11. Okay. What's that? Is that 1? Negative 1. Negative 1. So over here, at a 2, gradient's a negative. So I'm going to put a negative gradient there, just as a visual aid. Okay. I'd like to choose another nice simple number to figure out what's going on over there. Emily, what would you choose? 3. So then you're going to punch in 3 up here. Okay, 3 times 4 minus 36 plus 11. 12 minus 36 plus 11. What's that?
Three times 9.
Oh, 3 times 9, my bad. 3 times 9. Thank you. What's that going to be? 2. It's going to be 2. Thank you for the correction. Over here. Like that. Okay. Let's go over, have a look on the other side, Manny. What am I going to sub in here? 1. So you do it one more time. 3 minus 12 plus 11. What do we get? We get 2 again. Okay. So what is this guy right here? What's the nature if I'm looking at all my gradients along the way?
It's a maximum.
It's a maximum. Because it's going like that. Over here, a stationary point is like that. It's a minimum. Okay. It's a lot of work, but you need to be able to do this. Obviously, your CAS will do it straight away. Okay, but you need to get used to doing that. Okay. I might leave it there. There's one example. Okay. Do you guys want me to go through it, or would you like to read through it yourself? Okay. Read through it yourself. It's not very long. You'll get an idea of the previous work that we've done on that. Okay, when I do give you the notes, please correct. I'll say which one to correct.